Hello and welcome to a Blender Basics tutorial video. In this video we'll be talking briefly about bones and rigging and how we can create a basic armature for Spark AR. In this video we will not be going through kind of the complexities. We won't be, for example, building something like you can see on screen at the moment. We won't be talking about how to create a human rig. I'll kind of briefly go over why. But the fundamentals are the same. For example, let me just give you a quick kind of preview here. Just make sure the rig and the model are attached. So we won't be going through the complexities of boning. So we won't be going through the complexities of rigging and creating bones with Blender. We'll be going through this a very introductory kind of approach. So we won't be generating anything like you can kind of see on screen at the moment, where we're creating a humanoid that kind of has all the complexities and challenges that brings. But we'll be talking about the fundamentals of how we create bones and how we can introduce those into Spark AR, either as a pre-made animation or as a factor or something that we can animate within Spark AR itself. So without further ado, let us begin. So as you're probably already aware, if you've played any video games or watched any VFX films, you'll be kind of aware of this principle or this term called rigging. So whenever we create something, a kind of 3D model or something that's going to have, quite some animation to it, we have to create a skeleton. So like in the real world, we're made up of bones, and then we have muscles attached to those bones which constrain how much those bones can move, and then we have the skin and all that on top. We have to go through a similar process when we're working with 3D models. So what we have on the screen at the moment is an example of a humanoid structure. This is actually using the inbuilt Rigify tool. So if you've never used that, the way you get to it is by preferences, add-ons, and you just search for Rigify, enable that. And what that allows you to do then is when you've got a humanoid T-pose, and the reason we use T-poses typically is actually because it's easier to create bones along a straight edge. We don't really want to be creating bones where the model is already at an angle. It just makes life a lot harder. But yeah, basically you can create armatures using the meta rigs, the inbuilt tools, but we're going to talk about the principles of basic bones, single bones fundamentally. And all we're going to be creating today, nothing glamorous, is we're going to be just creating a cylinder and having that cylinder bend and warp essentially, and then introducing that into Spark AR. So we will possibly come back to more advanced rigging in the future, and we're looking at game engines and a wider use of these sort of tools and principles. But for today I just thought I'd start off by introducing you with the kind of concept, the core idea, before we get into the kind of crux of it all. So I'm just going to create a new project. There we go. And I'm just going to quickly create a cylinder. Nothing amazing, something super basic. And I'm trying to, whenever I'm creating anything or working with Blender, and with the idea of it actually going to be used in Spark AR, for example, or game engine, I ideally want to try and keep everything to the 0, 0, where the axes meet, to create our central pivot point. It just makes life easy when we're moving models around. That's the point that typically most of these programs use as the kind of control for position, for example. Now, if you've got the Spark AR toolkit enabled, you can actually open this up, select your shape, and just hit bottom, and that will automatically do it for you, likewise with center. So if you've got that enabled, and I've done a video on that before, it will make life easier. If you're not aiming to use this for Spark AR, then don't need to worry about that. So I'm just going to make the shape a little bit more taller. There we go. And go back to object mode. So with my object mode selected, I'm going to press Z to bring up my wireframe view so I can actually see where I'm adding my bones. Now, if we're creating bones for Spark AR, we want to have our bones kind of kept to a scale of 1 to 1. Blender and Spark works in a measurement of meters. So if I, for example, if I import this into Spark as it is, it's going to be huge. I will have to scale it down. In fact, I'm going to scale it down using Spark AR Toolkit just to make my life easier. But basically, if you can work on the principle of the scale and work out how your Blender's configured, then you can kind of have a rough idea. You can always scale it down in Spark AR afterwards anyway. We're still trying to keep to the principles of low polygons, not using too many vertices, too many kind of triangle data, just because, again, there's a limit on how much memory Spark can handle. So with our object selected, I'm going to press add, and I'm going to add a armature, and I'm just going to add a single bone. So this will be the option you have if you don't have Rigify enabled. And the way we kind of view this is the first bone that we add is typically what we're going to use as our root, our controller, our central point. So if this was a human body, like I sort of said, and we think about how our bones are going to be structured together, we have everything is grouped up together. So let's say our left arm is one group, our right arm is another group, but those groups are attached to a central controller, which in this case would be the torso, which is also attached to our neck, which also has its own group, same with the legs, etc. And essentially everything follows the parent. So when we talk about parenting and childing, the childs are always follow where the parents go. That's basically the kind of implying by that. So we're just going to create this first bone. This will create an armature. This first bone I'm just going to call root. So when we're naming things, we want to try and have a naming convention that makes sense. So because I'm making a generic shape, it's not really going to make much sense what I call things. But if I was animating an animal, then I'd have left leg, right leg, fingers, toes, whatever. You know, naming each individual bone that's going to be animated and moving its own corresponding name. Just so when we're introducing into another program or within Blender itself, it just makes our life a bit easier with that process. So with my armature selected, I'm going to go to edit mode, and now you should see it's sort of filled in. You can also see that via the little side menu here, which again, if you don't have it, you just click on this little side here. You have options to adjust the head, the tail. So let's just show you what that means. If I adjust the head, it will actually adjust the kind of position of that joint. So the way to think of it is the pyramid is essentially the solid bone, and the spheres or the joints are basically the rotation angles. So solid bone, ball joint, things rotate around the ball joint. That's again essentially the principle. So with that selected, I'm going to press Shift and E, and Shift and E basically is extrude. It adds a new bone to our existing root armature. I'm going to press Z to basically force this bone to stick to the Z axis, because I want to keep this in a straight line because I'm working with a straight model. Again, we don't really want to be animating things that are bent too much to begin with. It just makes life a little bit harder. And I'm just going to click and add it. And I'm just going to add a few more. So again, Shift and E, Z to confine to the Z axis. I'm just going to add a few of these. Now, the thing to remember with how bones work in Blender is it basically takes the first bone, which is our root, our base, this one down here, and the final bone here, and anything in between that we warp or conform will distract and deform that shape, but it won't follow the bone structure. We'll see what that means in a second. To get someone to follow the bone structure, we need to look at branching, and again there'll be a link in the description down below from the Blender's official site that talks about the bone tool in more kind of detail and the kind of principles of how we look at groups and the structures we should follow, but we're just going to work with the principle of one straight line, and we're going to get that to basically wibble and wobble around a little bit. So I'm going to go back to object mode. I'm going to select my shape, so this would be our 3D model, making sure it's all grouped together in one model. I'm going to press Shift and then click on my armature. Oh. So there we go, so we should have them both selected. I'm going to press Control and P to bring up our parent tool. Now this is where we have a few options. Now I'm going to keep with automatic weights, but we can actually change the weights of these bones. This is how much these bones influence the shape. We can also paint weight, and again we'll probably look at that in a follow-up video. We're not going to cover it in this video, but basically not every bone and every joint would have the same flexibility. So for example, my arm can only go that far and that far, but if this was, for example, a kind of ball joint position, it could possibly go almost 180 degrees back on itself, you know. So we can confine how much that can push and distort our model based on weight, essentially. But I'm just going to go with automatic weights because this is just an introductory video. And this should now mean if I go up to this option here, I've got this option called pose. This also means that now my cylinder or my 3D object is now a child of my armature, like so. So if I go to pose mode and I select one of these bones here and I also hit R to rotate, you can see as I rotate that bone, everything above and below that bone is being pushed and pulled, with the root, the first bone, the bit here being our anchor. So that is staying to the ground and the top is bending, with the middle kind of forcing its shape a little bit. So if I was to, let's say, rotate this back this way, you can see how it's not following that bone shape, but instead it's been influenced by the positions of the first and second. So again, if we was looking at this as a hand, we'd have a group here that each finger would follow this, but then each of these would have its own independent movement, and that's basically branching. So what I could do at this point is, let me just go back to solid here, is I could actually animate within Blender. So I could go to animation and let me just reset my values there. I can select my armature, and in fact at this point I'd also rename my bones. So at the moment it's just called root 1, root 2, root 3. This is where I'd rename them bone 1, bone 2, bone 3, or wrist, knuckle, fingertip, that kind of thing, you know, depending on what the object is you're animating. The better the naming conventions you can have, the easier it will be for somebody else who would pick up your project to work out what's going on. Likewise, when you get into more complicated 3D rigging, it just makes life a lot easier if you kind of come back to it next day, for example. Not bone, bone 3, there we go. Down here you can see we have some, within the pose view we've got options for adjusting the rotation of a bone, so we can actually keyframe things via typing in values. Likewise, we can also add bone constraints, so we can add things like whether it has a inverse kinematic. So sort of kinematics is, if you look at when we move our arm backwards here, it's also having an influence on the position of our shoulder here. Likewise, when we step forwards, our body sort of balances itself out, so it'll sort of lean back a little bit as you move forward to balance itself out as you step. That's basically kinematics. It's how the body and all the other bones react in relation to each other. And inverting that means instead of it going like this, it would actually go like this, if that makes sense. And again, we'll look at that in a more advanced tutorial down the line. So I'm just going to set these values here. So hit record and just go click, 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 click to set all of my values. And in fact, I actually want to keyframe everything, so I'm just going to keyframe all of my roots. Like so. Let's just undo that. It might be easier for me to actually animate the final position and then revert back, so that's what I'm going to do. I'm just going to go to, let's say, 60 seconds with the record button enabled. I'm just going to go back to wireframe so I can see my bones. It's still in pose view, and I'm now going to animate some rotation. I could also animate its position, although it's still anchored, so I can't move its position along the X and Y, and you'll kind of make sense why when we're looking at how the root is anchored. So that's just a thing to bear in mind. Quite often with things like walk cycles, there's two approaches. For example, you'd either have somebody walking on the spot and then move the model to that speed, or you'd actually have them walking through a space. Typically they'd walk on the spot and you move the model walking on the spot to the speed of which their leg movements touch the ground. So create those keyframes there. I'm just going to go back to the beginning and set these all back to 0. So they are all back to how they were originally. Doing this with every joint that I've moved. There we go. So now if I hit play, it will now twist and deform like so. I'm going to change my number of frames to, let's say, 60. So it goes and distorts. Now this is where we've got two options. We can either export our animation that we made in Blender and use that in Spark, or we can actually animate within Spark itself. I'm going to go through both ways. So I'll first cover how to use the animation we've created in Blender in Spark. If you don't want to do it that way, you can skip ahead and I'll put the time code on screen at the bottom when we get to that stage. But for now, I'm kind of happy with how it is. Again, like I said, this is a super rudimentary introduction. I'm going to go to File, Export. I'm just going to export this as an FBX. I could also use the Spark AR tool, so back to object mode. And I could export this as a mesh with a GRLT, but because I've got animation, I'm just going to export this as a FBX or OBJ. I'm going to go with FBX. We want to make sure that our values are set to be Z forward, Y up. And that's just a way that Spark interprets orientation, basically. I'm going to keep my animation baked. I'm going to save this to my desktop and just call this cylinder or cylinder, whatever. That's probably not spelled correctly, but it's fine. We'll press export. And now at this point I should be able to open up Spark AR and we can now start importing this. So I'm just going to create a new project. I'm going to use a face tracking. I'm not actually going to parent it to the face. I'm not actually going to use the face in this. I'm going to cover that in a future video, or actually link you to videos other people have made, because there are some out there already. So depending on how people receive this video, really. I'm just going to go to File, Import, and import the cylinder. And then I'm going to drag this onto my scene camera like so. I'm just going to scale this down because it's a little bit on the large side. You'll notice that under our cylinder assets we have our armature action animation. We have our material, so we could have created material and showed it. I didn't do in Blender, I'm just exported it out. So I'm just going to change it to standard just to make it a bit more clear. I'm just going to move this as well so it's in shot and move this to the bottom like so. Again, I'm not worrying about how this looks. This is more how to import a rigged model into Blender and basics rather than actually any end goal. We'll look at end goals later. I'm actually working on a fairly complicated effect at the moment where we're going to have tendrils like a Cthulhu effect that kind of sway as you move around. There's a lot more to it than that, but I'm looking at introducing those concepts when we kind of build a end product rather than just making it for the sake of it kind of thing. So I'm just going to, now I've got that in there, my animation may be frozen at a different frame depending on what frame I exported my object at. If it looks a bit different, that's probably because it's just chose a frame within your animation, so don't worry about that. But at the moment, the animation's doing nothing. It's not playing. There's no control. There's no anything. So I'm just going to go to Assets, Add Asset, and add our Animation Playback controller. Oh no, not Audio Playback. That's a very different thing. Animation Playback controller. Select my animation clip. So this is the one that was created in Blender, like so. We can also adjust the speed, the rate, etc., etc. I'm going to go to my cylinder, and you'll notice here under animation we have no controller selected, but I can now choose my animation playback controller that I've created, and we should now have our animation that we created in Blender on a loop. I can adjust the speed so I can make it a lot faster. I can make it so it doesn't loop and it just plays once and then freezes on the last frame, and it will reset when the effect is relaunched or the reset option is triggered. And so let's say I want to now control this and make this animation play at a kind of designated time. So the way I'll do that is I would go to my animation controller, I would choose something like play, and I'd say I want this to play when a certain input is triggered. So let's say when the user taps the screen, I want it to trigger this animation to play, so it'll be a switch, and I want this to turn this animation on when the user plays the screen. So let me just reset it first. So when I tap the screen, the animation plays and then it finishes. It doesn't reset because there's no reset control in there, because I'll turn loop off. So if I was to put a reset in there, and we put in a, try to remember the name of this one, a pulse, that's it, that's one, it's off my head. So we have our pulse linked to our gesture control, so that's flipped on. When that's turned on, we want that to be enabled. When that's turned off, we want that to reset. This is probably not the most optimal way of setting it. There's probably a better way of setting this up. In fact, I'm pretty sure there is, but that's not the purpose of this video necessarily. So now when I press the button once, it'll play, but it's already played the animation. If I press it again, it will reset and then play. So double clicking resets, pressing once plays, basically. Or again, if I have loop animation on, it will just play indefinitely. So that is how we can trigger animations. Those animations can be triggered when a mouth opens, when the user performs an action after a certain amount of time. There are plenty, again, if you look at other videos within my Spark AR playlist, you can look at any control input and output that within here. Again, if we're using patches, we are confined to what inputs we can plug into the control, so just bear that in mind. Okay, so we're now going to skip all that and ignore the fact that we've created an animation controller. In fact, I'm going to delete my animation controller because I'm not going to use that. And we're going to look at how we can control our bones and our rigging within Spark itself. So if we look at our cylinder here, and we've got, you notice we've got this thing called armature again, like we did in Blender. If we open that up, we have our skeleton, and within there is our root. That's our first bone, as you remember. And then we had our 4 bones like so. Now if I zoom in here really closely, you might struggle to see it because the colour is quite similar. In fact, let me just change the colour to shape just to make it a bit clearer. There we go. You can see that we have our bones like so. Now the final bone isn't showing up, it's showing up as the point here, so just bear that in mind. But I can now select any of these bones here. I could hit R to rotate, and if I was to move any of these bones, I can manipulate my model. So again, if we imagine this as an arm, we could have everything from up here follow where this goes, and likewise anything from here follows on from this joint. And the way we can animate this is now, like as you can probably imagine, is we can either do this via JavaScript or via our patch editor. So we could, for example, have a simple animation or loop animation. We're linked to a transition, linked to our bones rotation, and let's say we want it to go 120 degrees on the y-axis, so it has this twist. I can adjust the duration, so I can make it 10 seconds. I can also make it mirror, so it plays forwards and back. In fact, let's make that a bit more dramatic, so let's go 400. So now, as you can kind of see here, it's twisting. Just to give it a bit more clarity, I'm just going to also have it twist on the z-axis. So now we have our shape animating and bending and conforming to the bones that we've put within our model. Now, this is, as you can kind of see, the most rudimentary kind of shape. We've not created anything that's representative of anything. We've just created a cylinder that twists and moves and distorts. But we can move these things and have these things controlled or linked to positions of our head, for example. So as we move our head around, we could have grass swaying as in the opposite direction to where we're moving, using things like exponential, I can't say the word, smoothing. So let me just, yeah, there we go, that word, basically. And then that linked to the position from our face tracker object. And so if we bring this in here, just to kind of give you a kind of quick oversight, we can use our 3D position value here and use that value to be inputted into the position or rotation of that bone within our model. Speaking of kind of adjusting the position of that bone rather than rotation, let me just pause that for a second. We can also, which is something that we couldn't do within Blender because it's a bit more rigid, we can also distort the shape by actually moving the bones in Spark that Blender would typically try and limit us from doing because of the weighting of our bones. So you can override that a little bit in Spark, so just keep that in mind. But yeah, that is all I'm going to really cover in this video. Like I said, this was an introduction to bones and rigging and how to take a basic animated shape, I suppose, from Blender into Spark AR, how we can do some basic controls. We will return to this in future videos. We'll look at how to create more advanced effects with Blender rigging and linking them to different triggers, like I said, like physics, such as swaying or collisions, etc. But I just thought, because it's something that not everybody's kind of necessarily familiar with, especially those who don't use Blender, may use other programs, and may have heard the word rigging but not actually explored it. It's not that complicated. The challenge comes from the kind of linking of the bones and the naming conventions and the ordering. It's getting it into your head that parenting and childs and how one thing follows another and everything has to be linked up. Now, when I position the bones in a shape that's a bit more complicated, I want to make sure that anywhere where the bone would be rigid or the shape would be rigid, that it's rigid, and anywhere where it wants to bend, I have the little spheres attached, and I want to make sure that the bones are matched within the mesh itself. If I have them external or not applied, you'll start to find things flying off or not being attached properly. So just bear that in mind. So remember to like, comment and subscribe. Thank you very much for watching, and I will be back again very soon with more Spark AR and general tech videos. Goodbye.